Are you taking it away? What do you mean?
Why is it written there triangle 3 and 4? What does that really do besides them equaling each other?
Well, 5 came from 4, right?
Mm-hmm.
And we were able to say, hey, since these are congruent, then the measures are equal.
Okay.
All right? So then we came over to the proof and said that the proof, or the flow chart, and said 5 came from 4. It only came from 4. So the way that this worked out was, we started with the proof of the given, that the complementary 1 and 3 and 4.
How you would prove that 1 is greater than 2.
I'll do that in a minute. So 2 and 4 are complementary, right? And so then we were wanting to prove 1 is congruent to 2. So we took the given, listed it, wrote it as our flowchart as a given 1. Then we said, okay, from this, because they're complementary, they add to be 90. Their measures add to be 90, right? So we did that, and that's definition of complementary angles. Okay? From that, we were able to say, well, if they both equal 90, then they both equal each other. You know, if their measures equal 90, then their measures equal each other. Definition or substitution, right? We just substituted it in. Next, we said, well, there's another given. So the flow chart so far went 1 to 2 to 3. And then we said, well, there's another given up here that 3 is congruent to 4. So we started with that, which gave it a separate flow. Right? From that, we were able to go, well, if these are congruent, then their measures are equal. Definition of congruent angles. So 4 went to 5. Then we used 5 and 3. And we basically said, hey, since these are equal, then I could basically subtract angle 3 from both of these sides using my subtraction property of equality, because I subtracted from both sides. Because they're both equal, that would get rid of them, and what's left is that angle 1 is equal to the measure of angle 2. Okay? And then with 6, we had to use both 3 and 5 to get to 6. Right? And then the last thing was, well, if their measures are equal, then they're congruent. And that's what we wanted to prove. We didn't want to prove that the measures were equal. We wanted to prove that the angles were congruent. So we had to come back to the fact that 1 is congruent to 2 via definition of congruent triangle or congruent angles again. And now 6 just goes to 7. So we got 1 to 2 to 3, 4 to 5, and then 3 and 5 to 6, and then 6 to 7.
So, but what about the minus angle 3? How does that? I know
This
angle
one?
3 and angle 4 equal each other, but why would you write minus angle 3 on both?
Because angle 4 minus angle 3 equals 0.
Because these are equal, I could write 3 and 4 here, but I was trying to make a point that I could write just 3 in both of them. It doesn't matter, or I could write 4 in both of them. It doesn't matter because they're both equal. And when I subtract them, it's like Payroll said, they're equal. They make 0. And then when I add 0 to a number, I just get that number. Good question. Anybody else? Okay?